Hello, in this video I'm going to show you a variety of ways by which you can perform functional group transformations for compounds involving alcohols and phenols. First of all, how do we synthesize alcohols? Well, we can start from an alkyl halide and then we can do an SN2 using sodium hydroxide, where the hydroxyl group is going to act as a nucleophile to install the hydroxyl there. Another method would be to use an alkene to install hydroxyl in the less substituted position, and that can be achieved using hydroboration oxidation. How about if we want to install the hydroxyl group in the most substituted position? Well, that could be achieved if we use oxymercuration demercuration. In that case, we employ the use of mercury acetate in the presence of water, followed by sodium borohydride to do the demercuration. But suppose you are not given the alkene and you have to synthesize it from an alkane. How do we achieve that? Well, from this propane, we can be able to create an alkyl halide if we use a bromine solution in the presence of light. And then we can do elimination of the alkyl halide to form the alkene. This reaction could also be reversed if we use hydrogen palladium to transform the alkene into an alkane. Other methods that you have learned is that you can oxidize an alcohol into an aldehyde. For example, if we use pyridinium chlorochromate, which is abbreviated as PCC, and this reaction works best in the presence of dichloromethane. So dichloromethane acts as a solvent. Okay? When this reaction is performed, it stops at the aldehyde. However, if you use a strong oxidizing agent like chromic acid, then the chromic acid will transform this primary alcohol into a carboxylic acid. It can also transform an aldehyde into carboxylic acid. So, like in this case, we can generate chromic acid from sodium dichromate in the presence of sulfuric acid and water. How about if we want to form an alcohol from an aldehyde? Then we can do a reduction. So we can reduce that using lithium aluminum hydride. This requires two steps. So the second step needs a source of proton. We can also use hydrogen palladium to do that reduction, or we can simply use sodium borohydride in the presence of methanol or water. Okay? Then how about if you want to synthesize a more substituted alcohol from an aldehyde? For example, in this case, you can notice that we have installed an extra carbon. So we are creating a carbon-carbon bond. The best way to do that is to use Grignard reagent. So in this case, we are only installing one carbon, so CH3 MgBr in the first step. In the second step, we need a source of proton. Grignard reagent is not compatible with acidic conditions, so therefore we have to first of all perform the Grignard reaction, and then we install the hydrogen to the alkoxide using that source of proton. Other reactions you could do is we can transform the alcohol into an alkene. But how do we do that? We know that hydroxyl is not a good leaving group. So the best way is to first of all transform it into something like a tosylate. So we use tosyl chloride in the presence of pyridine. And then in the second step, we can be able to do elimination if we use like sodium ethoxide. Okay. We can also be able to install tosylate. If we want to form an alkyl halide here, we can transform the alcohol into tosylate by using tosyl chloride in the presence of pyridine. And then in the second step, we need a nucleophile, in this case, the bromide ion. Then the bromide ion will do an SN2 with the tosylate to give you that product. Moving to the bottom, with our secondary alcohol, we can oxidize this to a ketone, in this case acetone, by using the methods we already mentioned. So here we can use PCC, or we can simply use the chromic acid. Because this is not a primary alcohol, there's no way to synthesize the carboxylic acid. It has to stop at the ketone. This reaction is also reversible, so we can do reduction using any of these methods we mentioned here. Okay, so we can do reduction to get us the alcohol. How about if we want to install an extra carbon? So we transform an acetone into tert butanol. Well, we can simply use a Grignard reagent, where the second step involves the use of a source of proton. Now, let us move to phenols. If you look at a phenol, this carbon here is fully saturated. So there's no way for us to oxidize that position. So when we perform oxidation of phenol, it ends up forming another compound which we call benzoquinone. And here again we can use either PCC or we can use chromic acid. Okay? And the benzoquinone can be transformed into hydroquinone. If we do reduction, remember reduction, we can use lithium aluminum hydride, we can use hydrogen palladium, or we can use sodium borohydride. So in that case, you can include any of those. And this reaction is also reversible. If you want to do another oxidation, it's going to get it back to benzoquinone. So just say oxidation using either PCC or chromic acid. Now, if you look at this reaction sequence, I could ask you, like, how can you synthesize something like this compound here, which is 2-butanol from an alkyl halide? Then you can follow these steps. So the first step is to transform it into an alcohol, and then you transform it into an aldehyde, and then you transform it into the product. Okay, so that's going to involve 3 steps. I could also ask you to do something like start from the alkyl halide all the way to tert butanol. Then that's going to involve this first step here. Your second step is going to be this one. Then your third step is going to be this one here, step 3. And then you have step 4. And then you have step 5. Okay,